were the days of Elijah.
Welcome to another mathematics video tutorial brought to you by Ronique Bernard. This is another CDP MATHS LAB Teaching and Learning Center production. Instructions. This lesson was not designed for entertainment. It was designed to be interactive, so therefore we are asking you to follow each instruction given to you by the tutor. If not, this video will be very useless to you and boring, so please follow each instruction. Remember to do all the try this questions before starting your worksheet. Listen carefully. Topic for the day is sets, and we're on lesson number 2. Content of this lesson. What do you think that may be? The first one is finding the number of what? Subsets. Or second, equal set. Or third, equivalent sets. Or fourth, union of sets. And finally, finding the number of elements in two sets. So therefore we'll be looking at finding the number of subsets, equal set, equivalent sets, union of sets, and finding the number of elements in two sets. So we're going to look at now finding the subsets. So your question may be, how do I do this? Now let's look at an example here first of all. If A is equal to 1, 2, 3, calculate the number of possible subsets of A. Now note, the letter A here is representing the name of the what? Set. Good. So what we're going to find now is the number of subsets that can be formed from this set. Now if you notice, now we have listed the member of what? This set. So now let's see how we can calculate the number of possible subsets of A. Now this is a formula. Now many of you love to use formulas, don't it? Now let's look at the parts of this formula. Now we have capital S, we have an equal sign, we have number 2, and we have a little common what? N. And note where the N is. Good. Now what does the S represent? Now this S here represents what? The number of subsets. So S is equal to the number of subsets. So therefore this formula that we're going to use now will use this formula to determine the number of what? Subsets. And this is 2 to the power of N. Now next, what does the N represent? Now the N represents the what? Number of elements. Good. So therefore this N should be what? Equal to what? 1, 2, 3, because there are what? 3 elements. So how do we use the formula? So once again, so we're saying that S is equal to the number of subsets and the common N is equal to the number of elements. So it's not supposed to be capital but common. Now step 1. So we're going to look at how we use the what? Formula. So step 1 is saying that you're going to replace the letter N, which is this N right there, with the number of elements in the set. So guess what? For us to know what number N should be, we have to count the number of elements in the set. Good? So therefore 1, 2, 3. So this N here is going to be changed to what? 3. Very good. So notice now that the N was changed, this N here was changed from N to what? 3. So that is step 1. So to get to know what n is supposed to be, you count the number of elements in the set. Alright. So step 2, you are going to multiply the number 2, which 2 are we talking about? This 2 here, by itself according to the number of times indicated by the letter n. So the letter n, which is what? 3, will tell you how many times this 2 must be multiplied by itself. And let's see how we do that. Okay, now note, how many times have we multiplied 2 by itself here? 3 times, because n is what? 3. So 2 times 2 times 2 will give us 8. Very good. So therefore, the number of subsets that can be formed from set A is equal to 8. And how we got that is by using this formula. Very good. Okay, so once again we're going to say now, if A is equal to 1, 2, 3, calculate the number of possible sets of A. So we're still on the same example, but note something now. What have I done here? I have listed what? Each element what? By itself. So we have 1, 2, 3 different what? Subsets of set A. So once again we can put 1 and 2 together, and we can put 1 and 3 together as well. So therefore we have listed another 2 subsets. So how many subsets have we gone already? 1, 2, 3, 4, 5. And once again we can put 2 and 3 together, and we can put the same what? Sets, because remember we have what? Equal sets, and equal sets have what? The same number of elements and the same elements. So this is an equal set. Good. So now we have 1, 2, 3, 4, 5, 6, 7 elements, and our last one is called an empty set. So these 2 sets are always important to be a part of the subsets that you can have of a set. Good. So therefore we can list them first of all single, then we can group them in 2s, and then we can group them in 3s, and then we have a empty set. So you can use this method to determine the number of possible subsets of A. So you have learned 2 steps that you can use. Let's continue. Now here is a beautiful part of the lesson. Try this one. Now as always, you're going to record the question, pause your video, and then you attempt the question. So let's read the question first. Given that set P is equal to 2, 4, 6, 8, calculate the number of possible subsets of P. So pause the video now and do that question. Okay, let's see if you and I have the same answer. Did you get this answer? 16. Now if you didn't get this answer, what are you going to do? You're going to replay the video to the point before this. Try this question, look to see if you had followed the correct steps, and if you had not, then you know where you went wrong. Let's continue now. So we're on our new concept, equal sets. What the word equal means? Okay, same as. So let's look at this example. Now set A is equal to 2, 3, 4, and set B is equal to what? 4, 2, 3. Now stop and look at both sets. What do you notice? Good. What can we say about these 2 sets? What did you say? Come on, tell me. Alright. Okay, let's see. Note now that there's a 2 in set A and there's a 2 in set B. Note that there's a 3 in set A and there's a 3 in set B. Note that there's a 4 in set A and a 4 in set B. So guess what? They have the same elements and the same number of elements. You could just look at it and write that description. So they are equal, and we say that equal sets have the same elements and the same number of elements. Very good. Our next concept, equivalent sets. Can you tell me what's the difference between an equivalent set and an equal set? Let's see. Now there are two different examples here. So set C is what? A, B, and C, and set D is equal to 4, 2, and 3. What do you notice? This, how many elements set C have? 1, 2, 3. And how many elements set D have? 1, 2, 3. So guess what? They have the same number of elements, but they have what? Different elements. So what can we say about these two sets? Once again, they have the same number of elements, but different elements. So therefore, they are equivalent. But note, equivalent sets have the same number of elements, but not necessarily the same elements. So we could say that an equal set is an equivalent set, but not all equivalent sets are equal. Okay, let's continue. Try this question. Another excited part of our lesson, isn't it? Let's go. You know the routine, right? Determine whether or not if the following sets are equal. So x is equal to 6, 8, 10, 12, 14, and 16. And set y is equal to what? The set of even numbers from 6 to 16 inclusive. What's your answer? Yes, they are equal. Do you know why? Let's see. Now all these are what? Even numbers, and they start from 6 and they end at 16. So that's what inclusive means that you're going to include the 6, both numbers here, the starting number and the ending number, and evidently you get the same elements when you list them. Good. So the answer is yes, they are equal. Union of sets. Now set R is equal to what? 2, 4, 6, and 8, and set T is equal to 1, 3, 5, and 7. List the elements in R union T. So this symbol here means what? The union of two sets, and wherever you see it, it means the union of sets. Okay. Now, so the symbol means union or combine. So therefore, R union T can be read as R combines with T. And to combine means what? Take out your dictionaries and find the definition for the word combine. What did you see? To add. Yes, exactly. The word combines means to what? Add. So we're going to add the elements that are in R with the elements that are in T. And this is equal to what? Good. So what we have done, we have put them together. So we have 1 which is coming from set T, 2 which is coming from set R, 3 which is coming from set T, 4 which is coming from set R, 5 which is coming from set T, 6 which is coming from set R, and 7 coming from set T, and 8 is coming from set R. So what we do, we combine the elements of both sets. Try this one. Given that A is equal to 12, 15, and 18, and set B is equal to 13, 15, and 17, list the elements in A union B. Pause the video and try this one. Good. Let's see what your answer should be. Did you get this answer? A union B equal 12, 13, 15, 17, and 18. Did you get that answer? Well, guess what? If you didn't, here is a int. Wow. Listen to Mr. Int. Mr. Int says what? Each element must be written once. So maybe if you had written one element more than once, then that's why your answer would have been wrong. So when you see an element is repeated in two sets, you only write it once. Very good. So we're still on union of sets. Now given x is equal to 2, 4, 6, 8 and set y is equal to 3, 6, 9 and 12. Draw a suitable Venn diagram to show the union of two sets. So that is what you're asked to do. You are to draw a suitable Venn diagram to show what? Union of two sets. Okay, so now you're going to just once again take your pencil and you're going to draw this rectangle which represents the what? Universal set, which is a Venn diagram. Now of course you must have your what? Symbol. Now there are two symbols that are used for the universal set, but we'll use a capital U, a funny looking U, and then another one is a funny looking E. It's find it in most textbooks. Now you're going to draw a circle. Now you draw another circle. Now why didn't we use another diagram? Now why we use the intersection diagram? Because guess what? Note, you have to look into both sets and to see if they are sharing anything what? Common. Now they are sharing what? 6. So 6 is common to both sets. That's why we use this diagram. So we'll label them this as X, label this as Y. So guess what? Now let's list the elements in X. So we have 6, but first of all we're going to put 6 then. The 6 here because 6 is common to both what? Set X and set Y. Let's list the element of X now. 2. So which where the 2 is coming from? Right there. 4. 4 is coming from? Right there. And 8 is coming from there. So we do have to list 6 right here again because it is in what? Set X. If you look at the circle right here, it is still in set X. If you look at the circle right here, it is still in set Y. So let's list the other elements of set Y now. So we have 3 coming from there, we have 9 coming from there, and 12. So we have just listed. So you have to do this first before you can actually show the union of two sets. Now the next step that you have to carry out now to show the union of these two steps is what? Take your pencil and draw a line. So you can draw several lines to show the union of the set. So this is how you show the union of two sets. So you make sure you follow that step by step. Very good.
Okay, now my good friend, you are gonna now take this worksheet, which is supposed to be a part of your handout that you have received. Now we're gonna be looking at analyzing the set relationship. But what I want you to do now is to actually complete this worksheet first before I show you how to. So pause your video now and do this. Okay, very good. Let's see if you and I have the same answers. But before we go through the answers, let us look at what we have in front of us here. Now here we have a Venn diagram, as you can see, usually represented by a rectangle, and we have the symbol for universal set. The symbol here means universal set. Now these two circles now within the rectangle represent subsets of the universal set. So X is a set, which is a subset of the universal set, and Y is a set, which is a subset of the universal set. Now looking at these two circles, they are joined together, and when they are joined together like that, like one is looping over the other, we see that they what? Intersect. Now inside of them you see different numbers. Now those numbers are elements of a set. Let's take for example set X. The elements of set X are 4, 2, 8 and 6. Good? So there are 4 elements in set what? X. And the elements elements in Y is 3, 12, 9, and 6. So there are also 4 elements in set Y. So both set X and set Y have what we call elements. So in this rectangle now, what they have used this rectangle to do is to show the relationship between the two sets. However, what they have done, they listed the members in each set. So they have listed the elements or members of each set. Good. Now if you look at the outside of your rectangle here, your Venn diagram, you see that there are 2 elements. Good. Now normally in some exam questions, it states that it uses the word neither. Now, so these 2 elements, they are not in either set X or set Y. So they don't belong to any of these sets. So place them on the outside. Very good. Now, let us look at this rectangle at the bottom here. This Venn diagram. We're going to use this Venn diagram now for a different purpose. Alright, let's go back to the table now. Now, you should have completed the following table using the diagram above, which is this. Now, if you remembered what this meant, this common N with a capital letter in between brackets suggests you're going to tell the number of elements in set X. So you have X right there. So the number of elements in set X, let's count. So you have 1, 2, 3, and what? 4. So there are 4 elements in set X. So we write 4 right there. Did you get that one right? I hope so. Okay. Now, in set Y, we can count another 4. 3, 12, 9, and 6. So that is what? 1, 2, 3, 4. You see that? Very good. So you could say that they are equivalent as well. They only have one common element. Now, this symbol here, very crucial that you remember these symbols. It means to intersect. Now, once it's to the end and the outside, doesn't matter how many lessons are between the brackets. We are talking about the number of elements. Now, of course, X intersects Y is a set of itself, by the way. But how many elements are in that set? X intersects Y. That will be what? 1. That's a 6 alone. So that will be 1 element. So you write a 1 right there. Good. So here's a 1. Now, this symbol right here means what? Okay, I heard you. Union. So we want to talk about the number of elements that forms the union of X and Y. And earlier on in the lesson, we spoke about what union means. And union means what? When you combine both what? Sets. So when we combine X and Y, how many elements do we get? Let's count them. 1, 2, 3, 4, 5, 6, what? 7. Good. So there are 7 elements there. Now note, we did not count the 6 what? Twice. All we counted is what? Once. Very good. Now, if you look at this one now, look at this symbol right here. Pay attention to it. See it? Can you see it? Yes, it means what? Complement of. So I don't know how many elements does not belong to the union of X and Y. Why? If you look in your Venn diagram, you can see 1, 2 of them. They don't belong to the union, do they? Good. So you put the number what? 2 right here. Now, this is saying the number of elements in X only. Good. So if you count X only, means that if you count 8 is not in Y, 2 is not in Y, and 4 is not in Y. So they're only in what? X. So the region right here represents what? X only. So that will be 2, 4, and what? 8. So that's what? 3. If we do the same thing with Y, Y only, you count the numbers that are inside of Y but is not inside of what? X. So therefore 3, 12, and 9. So this is what? 3 as well. And that's information on the table. Now below now, another section of your activity, it says that you're going to list the elements in the following sets. So we're going to list the elements of X what? Complement. And remember that means what? Elements that are not in X. Good? Alright, let us look at the elements that are not in X. Now 3 is not in X, 12 is not in X, 9 is not in X, and 1 is not in X either, neither is 5. So we have our elements here. So we can start with the lowest. So we have 1, throw a comma, the next lowest is 3, throw a comma, the next lowest is what? 5, put throw a comma, and the next lowest is what? 9, put a comma. The next lowest is what? 12. Very good. Now, why complement here that we have right here. The y complement